Good morning, or perhaps afternoon, grade 8s. With some Rossini in the background, William Tell over Tell. Let's go into number pyramids like those last ones we did in class. And I absolutely loved Kongawa's way of going, oh, well, I did this minusing and it worked out. And well done to all of you for engaging with that question. What we're going to move on to now is using the algebra to help us with these. So I'm going to look through a bit of a method here. So in order to solve these last two number periods, you kind of trialed an improvement. Well, yes and no, because as I said, Kongawa, well done, and others that didn't get a chance maybe to speak on finding a good method. But we can come up with, as it says in the workbook, a more economical way. And this is where algebra is really, really handy. So we can say, well, let's build up our number pyramid and say, we want to find out what this bottom number here is. So it's written all over the page. What letter do you think would be good to use at the bottom here? I'm going to go for an X, but there's nothing to say that it has to be an X. But hey, generally we do use X's, remember? So if this is X, then we can write these other blocks, and this is a good bit of terminology to get used to in terms of X. So if this one here is X, then this number here, in terms of X, so an expression that has X's in it, what's this number going to be? Yeah, so I'm interested to see how you put it, but in fact, I'm jumping ahead here. We would add these two numbers. Now I'm going to say, well, we'd normally go 4 plus whatever that number is. So in this one we said 2 plus 7 gives you 9. 11 plus 14 gives you 25. 3 plus 2 gives you 5. Minus 4 plus 3 gives you minus 1. So 4 plus x. 4 plus x must be what's sitting in here. 4 plus x. So that's what's sitting in that block here. So in a similar vein of logic, what's going to be sitting in this block? Well, it's the sum of the numbers below it, so x plus 3. Okay, let's write it, x plus 3. Cool, so we're looking good so far. We haven't got our answer, but I have confidence that we're going to get there in a nice way. Or nice way, whatever that means. Okay, so now let's look to see how we can use this to get a really efficient way. Since we know that the two boxes in the middle, so let's add some colors in here. This box here, when we add it to this box here, we're going to get the box at the top, this box here. So I'm actually going to do that with those scribbles. It's going to say that box there, that greeny one, plus if we add this orange box, so if we add this one, we should get the number at the top. Given that, what do you think our equation is going to look like now? That's going to be our equation. Oh, I love it. Do. Anyway, so we've got this block here. Well, we said we could write this as 4 plus x. That's what we had over here. 4 plus x. And in this block here, we said, oh, we could write that as x plus 3. So if we add those two blocks, we'll get the top block, and the top block is 11. So in other words, we've got a nice equation here. So let's write it without these blocks part and go. So we got 4 plus x plus 3 equals 11. I think it's useful simplifying this left-hand side before doing anything else. So let's look at all our x parts and say, well, here we've got an x plus, so we've got a positive x and we're adding another x. So what can we simplify that to? Well, that's the same as 2x. And for our other part, let's go in blue here and say we've got a positive 4 and we're adding 3, so therefore what do we have? Positive 7. Doesn't matter if you put positive 7 plus 2x or 2x plus 7, either way, and this equals 11. Now, it would be nice if we just had 2x on the left-hand side. So what can we do to both sides of our equation? Remember, nothing's moving magically across anywhere. What can we do to both sides of our equation so that on the left-hand side we just have 2x? Well, I would say we can subtract 7 because then these two equals 0 and eliminate. So therefore we can subtract 7 on the right hand side. So 11 minus 7 gives us, let's stick in our blue, why not, 4. What can we do to both sides of our equation so that we just have x on the left hand side? So we just got x equals our final answer. What can we do to both sides of the equation? I think we can divide that by 2 because we're going 2 times x, so let's do the opposite kind of idea. So 4 over 2, so therefore x equals 2. Okay, so let's fill in our number pyramid and say, well, if x equals 2, what is the value in, what did we have it in here? In the pink, that worked out nicely. So what is the value over here? Okay, well, it's 2 because that was x. Then let's go to our green block up here and say, well, our green block over here, if x is 2, what is this value? Now, I hope that you said 6 because 4 plus 2 equals 6. Also remember that this one here we said was 4 plus x. So if x is 2, then this is 4 plus 2, which gives us 6. So 2 different ways of seeing what it is. And finally, what is going to be in this block here? And I want to push you to think of it in terms of x plus 3. So if x is 2, what is the value in this block? Well, our value is going to be 2 plus 3 because x is 2, which gives us 5. Of course, it makes sense from our diagram that it's 2 plus 3 as well. Okay. Let's just relax for a little bit. Okay, feeling relaxed and calm. So for exercise 5, we've got a nice strategy that we're going to use. And we're going to put an x in the bottom. And with a jump of music, we're going to put an x in the bottom and then fill in the other blocks and set up our equation. Yesterday or on Friday, whenever it was, we seem to prioritize the prime numbers. Let's go for these non-prime numbers. Notice I'm not saying composite because one is not. And so let's do, whoa, that's exciting. Isn't this, yeah, anyway, okay, let's not go for composites actually. Sorry, I want to get a nice range of questions here. So I want you to do those and that, and that's enough actually. So 1, 5 and 8. You're welcome to look ahead at the next bit. These are a similar type of idea. I feel like you're on the horse. Goodbye.